Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at Eulerian and Hamiltonian paths. We start with Eulerian paths, so called because they're named after Euler, who first came up with them. So a path is just a way to get from one vertex to another. Now we call a path Eulerian if it traverses, so if it goes through each edge once and only once. An Eulerian circuit is the same as an Eulerian path, but it starts and ends at the same vertex. So I know that's probably complicated. I'll show you exactly what I mean in a second. I just want to go through the blue here because there is a nice condition that tells us when Eulerian paths and circuits are possible. So an Eulerian path is possible if and only if there are either no vertices of odd degree or exactly two vertices that have an odd degree. An Eulerian circuit is only possible if all vertices are of even degree. Okay. Probably doesn't make a lot of sense. So let's look at an example here. Let's decide whether an Eulerian path and Eulerian circuit are possible. So if we're determining whether or not these are possible, we just need to look at the degree of each of the vertices. So let's go and write that here in green. So the degree of this vertex here is 1. There's only one edge emanating from it. The degree of this one is 3. The degree of vertex 4 is 2 because there are 2 edges, and so on. So in this network here, there are clearly 4 vertices of odd degree. So what that means is neither an Eulerian path nor an Eulerian circuit is possible. We don't have to go any further. So let's look at this one here. Let's again write the degree of each vertex. So the degree of this one is 2 because there are 2 edges emanating from it, and so on. So if we go and find the degree of each of these vertices, we see there are exactly 2 vertices here that have odd degree. What all of this word salad up here was telling us is that that means that an Eulerian path is possible. An Eulerian circuit, however, is not possible. An Eulerian circuit is possible only if all of these had even degree. All right, let's find an Eulerian path. What this says is that if you have 2 vertices of odd degree, the Eulerian path will start at one of them and end at the other. So I know that any Eulerian path is going to have to start here or here. So let's just start at vertex 2. So what we can do is start here, then go here, 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 and here. So we started at vertex 2 and ended at 3. If you follow that sequence there, that is an Eulerian path. It goes through each edge once and only once. It doesn't matter if we visit vertices or nodes more than once, but we can only go through each edge once and only once. So what I showed you there is an Eulerian path. It's not an Eulerian circuit because I didn't start and end at the same vertex. I started here and ended there. An Eulerian circuit is not possible. You can't draw an Eulerian path here that starts and ends at the same vertex. All right, let's look at this one here. So once again, to decide whether or not an Eulerian path is possible, let's look at each vertex and its degree. So writing the degree of each vertex, we actually see that each of them has an even degree. So what that means is both an Eulerian path and an Eulerian circuit is possible. And because each of them has even degree, you can start wherever you like. So let's, for example, start here. We go here, 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 and here. This is an Eulerian circuit because we started at vertex C, we ended at vertex C. We went through each edge once and only once. It doesn't matter if I visit vertices more than once, but each edge was traversed once and only once. All right, let's now look at some Hamiltonian paths. So paths are called Hamiltonian after the name of the guy who invented it. So a Hamiltonian path, rather than traversing each edge only once, each vertex is visited once and only once. Similarly to what we saw with Eulerian paths and circuits, a Hamiltonian circuit is the same as a Hamiltonian path, but it starts and finishes at the same vertex. Now, unfortunately for Hamiltonian paths, there isn't a nice condition that tells us when they are possible, unlike for Eulerian paths. However, we can use a bit of intuition. Let's look at this network here. So when we're asking, is a Hamiltonian path possible, we're asking, is it possible to visit each vertex once and only once? Now, we can see clearly the answer to that will be no here, and it's because of all these with degree 1. So how do they preclude the possibility of a Hamiltonian path? Well, the problem is that if I wanted to visit each of these vertices, I couldn't possibly doing it without visiting vertex C more than once. If I end up at C at some point and want to go to D, the only way I can go back and visit E, I'd have to go to C again and then to E. It's just not going to be possible. If a Hamiltonian path is not possible, certainly a Hamiltonian circuit is not going to be possible. A Hamiltonian circuit is a type of Hamiltonian path. All right, let's look at this one here. So it turns out a Hamiltonian path and circuit will be possible here. So let's just see how we go. So if we go A, B, C like this, if we follow this here, we have clearly a Hamiltonian circuit. It is Hamiltonian because each vertex was visited once and only once, and it is a circuit because we started at A and ended at A. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.